Hi, this is chapter 3, day 4, solving compound inequalities that are ands. And means both. So and means that both things have to occur at the same time, not or like the other day, right? If I say bring me an apple and a soda, you need to bring me both the apple and the soda, right? That's what and means. It means both. I'm going to be doing these on the smartboard today, so you might need to turn your volume up a little bit to catch my voice because I'm going to be a little further away. So and means both. You can get an and inequality two ways. Sometimes you're going to see the word and, like on these first two, but most of the time you're not, like in the other 4 problems that we'll look at. So to solve these ands, I'd solve like normal. To get rid of a minus 7, I would add 7. So I've got x is greater than or equal to negative 4, and is part of the answer. To solve the other equation, to get rid of a plus 2, inequality, I subtract 2. So I've got x is less than or equal to 10. So I want the numbers where both of these things happen, right? I need to have numbers that are going to be greater than or equal to negative 4 and at the same time less than or equal to 10. So I'm looking for where both of these happen. So my answer would be starting at negative 4, including negative 4. I want the numbers that are greater than negative 4, but I don't get to go on forever because they also have to be less than or equal to 10. So it's the numbers between negative 4 and positive 10. They have to be bigger than negative 4 and at the same time less than 10. So they end up looking like 2 dots shaded in between the majority of the time. Just like here on this next one, you divide by 5. So you get x is greater than negative 5 and solve this one by dividing by 7. X is less than 7. So here I want the numbers that are greater than negative 5. So I'm starting at negative 5, open because it's not equal to, greater than to the right, but I don't get to go to the right forever because they also have to be less than 7. Running out of room, aren't I? So here I was, I had this at negative 5, and then I was shading to the right, but I don't get to shade to the right forever because they also had to be less than 7. So that's my graph that represents the numbers that are going to be greater than negative 5 and at the same time less than 7. So the numbers between negative 5 and 7. So since it's usually happening between, there's a different way to write these. I call them smushed. That's not official, right? But the smushed ones are when you have 2 inequalities here in the same. See how there's 2 different inequalities? If there's 2 inequalities smushed together in the same problem, that is an and. And the cool thing about that is you can solve it in the smushed manner. So you know how like we usually say what you do to the left, you do to the right? Well, if it's smushed, there's actually 3 sides. So what you do to the middle, you also do to the left and to the right. So I can see here in the middle, I've got 5n. So to get n alone, I would divide by 5. If I divide by 5 in the middle, I divide by 5 on the left and on the right. I cancel, I clean. The 5 over 5 cancels. So negative 5 over 5 is negative 1. Less than or equal to n. Less than or equal to 45 over 5 is 9. So this is another way to write an and. It doesn't actually have the word and, but it's known to be an and because it's an in-between. So you want the numbers that are between, see how n is literally between negative 1 and 9. So we want the numbers that are greater than negative 1, including negative 1 because of the equal to. So we're greater than negative 1 and at the same time less than or equal to 9. And you can see how that just kind of looks at n is between negative 1 and 9. Filling in the dots because they were both equal to. So just like on this next one, let me write it in black. Original problem, negative 49 less than or equal to 7m less than negative 7. M is not alone, it's being multiplied by 7. So we would divide the middle, the left, and the right by 7. The 7 over 7 cancels. So negative 49 over 7 is negative 7. Less than or equal to m, less than negative 7 over 7 is negative 1. So just like it looks, I want the numbers, m's, the number m's between -7 and -1. So I'd have my dot at -7 that I would fill in because it is equal to, and I want to be greater than -7 and at the same time less than -1. So I want the numbers m that are between -7 and -1. Notice I filled in -7 because it had the equal to with the inequality. I did not fill in -1 because it did not have the equal to. Same thing on numbers 5 and 6. It's just that they're two-step inequalities, right? We've solved two-step inequalities before. So we have -33 less than or equal to 8x minus 9 less than 39. So looking in the middle there, to move a -9, we add 9 on the middle, the left, and the right. We cancel, we clean. So -33 plus 9 is -24, less than or equal to 8x, less than 39 plus 9 is 48. Now, to get x alone, he's being multiplied by 8. Opposite, divide by 8 on the middle, the left, and the right. 8 over 8 cancels. So -24 divided by 8 would be -3, less than or equal to x, less than 48 divided by 8 is 6. So I want the numbers that are greater than or equal to -3 and less than 6. So I go to -3, I put my dot, I fill it in because it's also equal to. I want the numbers greater than -3 and at the same time less than 6. So when I run this into 6, I had to head back the other direction. So again, notice -3 is filled in because of the equal sign, and 6 is not because it does not have it. Looking here on number 6, we've got -16 less than 4 plus 2n less than or equal to 18. So looking in the middle, to move a +4, I subtract 4 on the middle, the left, and the right. So -16 minus 4 is -20, less than 2n, less than or equal to 18 minus 4 is 14. To get rid of a multiply by 2 on the end, I would divide by 2 on the middle, the left, and the right. 2 over 2 cancels. I clean up. -20 divided by 2 is -10. Less than n, less than or equal to 14 divided by 2 is 7. So my smallest number I want is -10. I want to be greater than -10. I didn't fill it in because it wasn't equal to. And at the same time, less than or equal to 7. So I have a dot at 7 that I would fill in and then head back the other direction. So I want to be here. This is like I could write it also. N is greater than -10 and n is less than or equal to 7. Those are the two ways that you could write the same answer. And that is how you solve a compound inequality that is an and.